Hello there. Welcome to the first chapter of this module. In this chapter, we will study about motion. In this first session, we will discuss distance and displacement. Now, you already know a few things about motion, but let's start from the basics anyway. Now, a body is said to be in motion when it moves, and when it stops moving, it is said to have come to rest. So, the word motion means that the object or the body is in motion, and when it is not in motion, it is said to be at rest. Right. Now, there are various ways in which we describe motion. We define different parameters which are used for the description of motion. In this session, we will be talking about two such parameters, which are distance and displacement. You should also keep in mind that distance is a scalar quantity and displacement is a vector quantity. We'll come to it shortly. Now, whenever something moves, it takes a route or a path. The length of the path taken by the particle is said to be the distance covered. So distance is nothing but the length of the path taken by the particle. Right. So if, say, a particle moves from point A, goes to point B, and then moves back to point C, and say I tell you that the distance between A and B is 100 meters and that C is the midpoint of AB, then can you tell me what is the distance covered by this particle in question? I'm sure you figured it, that it has moved through 100 meters plus 50 meters, which is 150 meters. So this is the distance covered by this particle. Right. So distance is nothing but the length of path taken by the particle. Right. Let's now talk about displacement. Displacement is the shortest distance between the initial point and the final point. Let's come back to our example. You see that the initial position, when joined with the final position, this line is basically the displacement. So, in other words, displacement is the shortest path that a particle could have taken to get from the initial position to the final position. Also, displacement, as we have already mentioned, is a vector quantity, and it points from the initial point towards the final point, and its magnitude is obviously equal to the length of this line, or you could also say the length of the arrow which represents displacement. Right. So distance is the length of the actual path taken by the particle, and displacement is the length when you join the initial point with the final point. It gives you the shortest distance between the initial and the final position. Right. So the question that we had just seen, in this case, if you were asked about displacement, what do you think that would be? The particle first went up to B and then came back to C. Now, when we are measuring displacement, we are only concerned with the initial point and the final point. So when you join these 2 points, you see that the final distance between them is only 50 meters, and hence the displacement is 50 meters. Right. Now, if you recall, we had a sign convention for vectors. In that, we had said that the decision is with you which direction you want to take positive. Like in this case, if we had said that this direction is positive, then we can say that the displacement is plus 50. Right. Let's take a slightly more tricky example. Let's say that a particle goes from point A to point B, then further moves on to point C, and finally reaches point D. It is given that the path it is taking is basically a circle of radius 10 meters. So in this case, we wish to find the distance covered and the displacement of this particle as it goes from point A to point D via B and C. Right. So let's first think about the first part in this question, which is the distance covered. The distance it has covered is basically the length of sector ABCD. Now, I hope you know that in a circle, the total circumference is equal to 2 pi r, right? Where r is the radius of the circle. So if you have a circle of radius r, the circumference of that circle is 2 pi r, right? Now, if you have a small sector which subtends an angle theta at the center, then the length of this r is given by 2 pi r into theta by 360. Right. Now, in this case, the particle has gone from A to B to C and finally to point D. So if you think about it, we need to measure the length of this sector ABCD. What do you think is the angle subtended at the center? Think about it. You can see from the location of these points that each sector, like A to B, is basically a quarter of a circle, right? So these points basically divide the circle into 4 equal quarters, right? Now, the total angle there is at the center, if you measure, this entire angle is 360 degrees. That is also the reason we have 360 in the denominator here, right? So 3/4 of 360 would be 3 by 4 of 360, which is nothing but 270. You could also arrive at this by arguing that this is 90 plus 90 plus 90, hence the total angle 270 degrees. So the length of path, which is also the distance, is equal to 2 pi into r, which is 10, into theta, which is 270, divided by 360. Right. So this is basically the distance covered, and the value of pi, I hope you know, is 3.14. You should remember this value, right? So I'll leave the calculations up to you. Let's move on to the second part where we have to find the displacement. Now, as we have already seen, to find displacement, we need to join the initial point with the final point. So, to calculate displacement, let's join points A and D. Once this is done, displacement is nothing but the length of this line AD. Also, the direction, if you recall, we had said points from the initial position to the final position, and hence the displacement points in this direction, right? So we know the direction, we have identified the line, we only need its magnitude. So let's focus on the triangle AOD. If you look at this triangle AOD, AD is basically the displacement. Now, you should also notice that AO and OD are nothing but the radius of the circle, and that we know is 10 meters. So this length is 10 and so is this. And this we have already established is a right angle. So clearly the displacement can be found using Pythagoras theorem, which tells us that the hypotenuse is equal to square root of base square plus the height square. So we get these under root of 10 square plus 10 square. The square of 10 you know is 100, so this becomes 100 plus 100, which is basically square root of 200. Now you can write that as 2 into 100. 100 can be taken out of the root, so you get 10 into root 2. Root 2, we've already discussed, has a value 1.4, so this becomes 14 meters. So the displacement is equal to 14 meters. Right. Let's find an approximate value of this just to compare distance with displacement. You could cancel this with 3. You could further cancel it with 2. So what you have is 3 pi by 2. 30 pi by 2. So pi is 3.14. 3.14 into 10, let's approximate it to 31. So this figure is basically 31 into 3 by 2, which is nothing but 93 by 2, which gives us 46.5. So the distance covered by this particle is 46.5 meters approximately, while its displacement is only 14 meters. Right. So I hope you understand that distance is the length of the path taken by the particle, and displacement is simply the shortest path it could have taken to go from the initial position to the final position. So in this session, we learned about distance and displacement. We saw that distance is a scalar quantity and is basically the length of the path taken by the particle, whereas displacement is a vector quantity. It points from the initial point towards the final point, and its magnitude is equal to the shortest distance between these 2 points. Or simply put, it is the length of the straight line joining the initial with the final point. In the next session, we will discuss speed and velocity. Thank you.